All right, so week 4, right? Week 4 it is. So, it's just more practice with functions, and then we have a midterm. All right, the deal with the midterm is just treat it like any other assignment. You don't have to be here, take it. You can do it online, you can do it in pieces, you can do part of it now, part of it later. That's fine. The only difference between the midterm and the other assignments is I offer you all the points back on the regular assignments. So if you mess up on something, you're welcome to resubmit it. And if it's fixed, I give you all the points back. On the midterm, if something's missing, let's say you got 50% on the midterm, you bombed it, I'm offering you 50% of your lost points back. So you're still welcome to resubmit it, but you're not going to get all the points back. You're going to get half of them back, which is still not bad, because I don't expect you getting a 50 on the midterm. Okay, if you've done all the work, midterm is going to be a piece of cake. So, any questions about anything so far? Anything we've done? We're all good? I believe you. Okay, so what do we have to do for this week? Just, I don't know, I'm just gonna go over some of these assignments and just see if I can give you some clues. All right. So these first couple of ones are pretty straightforward. I don't even know what they are. So this one here is you have some kind of a function called cigar party, right? And I guess a squirrel party is successful and the number of cigars is between 40 and 60. If you don't know, squirrels like cigars. So if they have between 40 and 60 cigars, let's see. So if it's between 40 and 60, it's okay, it's a good party, unless it's a weekend, in which case there's no upper limit, right? So if it's a weekday, it's got to be between 40 and 60. If it's a weekend, it's got to be just over 40, right? And this here is going to be, I don't know, false, false, true, right? And lowercase. Okay, does that make sense? This is your function prototype. You should know what a prototype is. Any questions? We're all good? Sure? Anyone want any clues? Sure. You want a clue? All right. Here. So, I don't want to solve the whole thing for you, but I guess I'm going to. Bless you. Okay, so this one here is a cigar party, right? And this is your prototype. And let me zoom in a little. All right. So the actual code is going to be cout, I don't know, cigar party, and it takes a number of cigars, I don't know, let's say 40, and then something like true or false. Okay, so that's my call. All right, so it goes like this. In this piece here, this is the isWeekend, all right, parameter. So this is my function definition. All right, just again, this is prototype. Function prototype. This is my function definition. Definition. All right, you want the prototype before the main, definition after the main. You could get the definition and put it on top of the main and then get rid of the prototype, but that's not a good idea because then the functions have to call each other in a specific order. Like one function cannot call another function if the other function is defined after it because it wouldn't know where the other function is. So just for simplicity's sake, always just put the prototypes on top of the main, definitions under, and then it doesn't matter in what order you call these, right? So this is simple, right? The instructions were, right, if, what is it? Score party successful when the number of cigars is between 40 and 60, right? So you go in there and you do if the cigars is greater than or equal to 40, and cigars is less than or equal to 60. And you have to go and throw in some extra parentheses because that's what this thing likes. All right, if that's the case, then you return true. Right, and then the other one is if it's weekend, right? If this weekend is equal to true, right? I don't want to solve the whole thing for you, right? And then the number of cigars is more than 40, then you also return true. And otherwise, you'll have like a return false at the end of this whole thing. Okay, so I don't want to solve the whole thing, but basically you want one return true, then another return true, and then just the default return false. All right, and then when you call this thing, this is 40, and let's say this is false. All right, so it's not a weekend, and we got 45 of these, and if you run it, it should give you a 1. There you go, which is true. Okay, there you go. So that's your hint for P, I don't know what, P38. All right. So this is P38 hint. Okay, so that's one. The other one is 39. Given number 6, the number 6 is a truly great number. Given two int values a and b, write the function to return true if either one is 6 or if the sum or difference is 6. Does that make sense? Pretty basic, right? All it is just a function with an if in it. Check to see if one is 6 or the other one is 6, or if both of them are 6. You know, the sum or the difference is 6. So just write a bunch of ifs in there. Returns true or false. Okay, so that's that. Next one, 40. Right, so this one is given two integer values, return true if one is negative and one is positive, and except if the parameter negative is true, then return true only if both are negative. So it's just a basic exercise with logic. It's not, let me just change this to lowercase. Alright, these are all lower cases. False, 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 true, 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 right? And you have your prototype. Just write the definition and call the function. Any questions? It's just basic stuff with functions, nothing fancy. All right, it's just to give you more practice with functions. The other one, 41. 3 parameters, returns an integer. All right, given 3 int values, return their sum. That's super easy. However, if one of the values is the same as another of the values, it does not count towards the sum. All right, so you have 1, 2, 3, that's a 6. You have 3, 2, 3. You don't count the repeaters. If you have all of them are the same, none of them count. All right, so it's just, again, just simple ifs in there. Okay. That's that. Any questions? I'm sure you got it. All right. Next one is prime numbers. The prime numbers is a little more difficult. All right. And I have some hints in there. I don't know if that's going to be enough. So write a program that finds and prints all prime numbers between 3 to 100. Maybe I have some more stuff here. Yeah. All right. I'll give you some more clues. Okay. So one way to solve this problem is to use a doubly nested loop. The outer loop can iterate from 3 to 100 while the inner loop checks to see if the counter value for the outer loop is prime. All right, let me show you. So this is, I'm not even sure if it doesn't even have to do with functions, right? So there's no functions involved in this one. So I'll just throw it in the main. This is P42. P42 hints. All right, so first of all, everyone know what a prime number is? Anyone not know what a prime number is? I know Marissa doesn't know what a prime number is, right? All right, I'll tell you. Prime numbers, What's a prime number? It's a number that can be evenly divisible only by 1 and itself, right? Okay. She's the math major. Okay, so all right. So let's say, for example, you have the number 3, right? Can you divide 3 by 2? No. You can only divide by 1 and 3, right? Then you can go. So that's a prime number. 4. Can you divide 4 by 2? Yes. So that's not a prime number. 5. Can you divide 5 by 2? No. Can you divide 5 by 3? No. Can you divide 5 by 4? No. So that means it's a prime number. So the test is, if any number is not divisible by anything between 2 to 1 less than itself, it's not a prime number, right? So if any number is not evenly divisible by any number between 2 and itself minus 1, then that number is prime. Okay, so that's the general idea. Let me throw it on another line. Okay, so let's start with something. So I'm going to go in there. I'm going to do, first of all, I'm just going to start with some number, int num. Right, I'm just going to be equal to like 5. Okay, so what I'm trying to do is I'm going to try to divide 5 by 2, 3, 4. Right? So what I have to do first is I'm going to make a loop that generates these numbers for me. Right? So I go, all right, for, I don't know, int I is equal to 2. I is less than or equal to num minus 1, and then I plus plus. And I'm just going to do a cout, and I'll show you what I is. Alright, I is I and L. Alright, so when I run this thing, I should see the numbers 2, 3, 4. Yeah, close enough. Let me do an endl on this one too. Okay, one more time. 2, 3, 4. Okay, right. Let me change this thing to maybe 7 or something. All right, 7. So now it should just generate the numbers 2, 3, 4, 5, 6. All right, 4, 5, 6. Yeah, 2, 3, 4, 5, 6. Okay, so I can generate those numbers that I'm going to try to divide this number by. Okay, so now the next thing is, now that I know this works, I'll leave it in there still, just like that. Okay, so now I'm going to have to try to divide this number, my num, by all the i's. So if I do this, if my number modulus I is equal to 0, right? If it's evenly divisible, if the number is evenly divisible, it is not a prime. Alright, so I'm just going to do, if this is the case, I'm just going to break the loop. Okay? So let's have a look. You're not going to be able to tell anything really. But then the other one is, if I get to all the way at the end, if I get to the last number, and so first of all, this is going to kick me out of the loop at any point that a number is evenly divisible, right? So let's say I have the number 9. Right, I'm going to try to divide 9 by 2. It's not a 0. It's 4.5. You have a remainder, so it's not a 0. Then I'm going to divide 9 by 3, which is 3.0. No good. Now it tells you this is not a prime. Just get out of the loop. It's not going to show anything. Right? But if I get to the end of the loop, and we haven't encountered this yet, right? So if I get to the end of the loop, show the thing. Okay? So let's have a look. Let's try this. So if my, what am I going for? I, no, is it I? Yeah, I is equal to num minus 1, right? So I've basically I got to the last one, right? I didn't get out, I did not get kicked out of the loop, right? I got to the last one. Then I'm going to show you that that's the prime number. So I'll show you the number num is prime. All right. Does that make sense? I hope. Okay. So let's have a look at 9, right? So the 9 should not be that. Right? Nothing. Let's go and give it number 7. Try it. The number 7 is prime. Okay, so I caught that. All right, let's go and do another one. Let's do the 5. 5 is prime. Okay, let's do 4. Shouldn't get that. All right, so it's working for these numbers. And now all you have to do is make another loop, which changes my num from 3 to 100, because you're looking for the prime numbers between 3 to 100. And that's it. Make sense? So again, you just have to have some kind of an idea of what am I trying to do, and then just go ahead and write the program to do it. Nothing too fancy, actually. Okay? So if I get to the end of the loop, and we did not break, right? This means that the number, that num must be a prime. Okay, so that's one of the more difficult ones up to this point, I guess.
When you break inside of a nested loop, you're only breaking the inner loop?
Correct. If I have another loop here, let's say I have another for loop here, right? If I do a break here, that breaks this loop. It does not affect that one. You're going to have to have another loop, another break, right? And by the way, a lot of times people make this mistake. They'll have a break that's not even part of a loop, right? And it will give you the error like, well, break, look what it tells you. Break statement is outside of a loop. So that's a similar error that you're going to get when you run a program and you didn't put the break inside of a loop, okay? So make sure you put it inside of a loop. So that's the prime number business. All right, you got your hint. Go back. Okay, now next one, 43. All right. Type up some sample programs, right? Display 5.2, 5.3, 5.13, right? Just run the programs, get them to work, show me that they work, and then I ask you here, the original program did not work, so we commented the lines that are not working, broke them down further into little steps, and then used the cout to see every piece of data in every little step. So if you go to the, that's basically a debugging technique, right? The code's not working. You don't know why it's working. Break it down into little pieces, look at your variables, and then you're going to see with your eyes why it's not working. I have to do this a lot of times. Like if I get stuck on something, I can't see it, I'm not going to just sit there and get all frustrated about it. I'm just going to do some couts. I'm going to look at my variables, and it's going to pop up right in front of my eyes why it's not working, right? And that's it. So yeah, there was some kind of a problem, some kind of a bug in this program in 5.13. To go figure out what it is, right? Chapter 5. Let's just have a look at it real quick. So that is 5.13. And these are towards the end, I think. 5, 4. Okay. Let's try to zoom in a little more. This is 12. Okay. So yeah, you had some original program that wasn't working, right? And the reason why it's not working is because you have this 5 divided by 9 right here, right? What's going to happen if you do this? Integer division, They'll think, oh, you have one integer divided by another integer, 5 divided by 9 is like 0 point something something, but it's going to say, oh, it must be an integer, and it will cut off everything after the 0 point something something, so it will be just a 0. Then when you do 0 times whatever this, you're always going to end up with a 0 answer, right? And how are you going to show yourself that? Well, just show the different pieces of the equation. So that's what they did here. They broke it down into little pieces. 5 divided by 9, they put it into a variable. Then the other piece, this piece, they put it into a variable. And then just go and just go in there and you show yourself the different variables. They're going to show the conversion factor. They're going to show the temp Fahrenheit, and you're going to be able to see that conversion factor turned out to be 0, which is this variable right here, right? So the moral of the story is you have some big formula in there. It's not working out. Break it down into little pieces. Look at the individual pieces, and it'll just pop up why it's not working. That's the old school debug, right? There's fancy software that'll allow you to, pause the program and, debug it. And actually, C-Lion is pretty good for this kind of stuff, right? You can go in there and right-click right here on the side. Right-click. No, see this little dot that I'm putting? This, right? That's a breakpoint, right? It might even tell you. No, it doesn't say anything. But that's a breakpoint. What's a breakpoint? That is going to stop my program. Like if I hit the little debug button, right? Let's just try it. I run it. Ugh. I guess it wants more power. All right. It went straight to it. I think it's because, I was right after the first one. Let me get rid of this, put it right before the if. So it stopped, the program stopped before I could break it. So I'm going to put it before this, and let's try this now. There we go. So now the debugger kicked in, right? So this is a very useful tool when you work on some monster projects and you can't, just visualize what's wrong with the code. Because with this, you can see that it actually keeps track of your different variables. Like right now it has paused right here, right? And it shows you that the value of num is 4, the value of I is 2, and then I can tell it to go and step through this code, like step over, step into. If you have a function, you can tell it step into the function so you can look at what the function does. If you're already sure that the function works fine, you can tell it step over so it doesn't go into the function. Right, so I'm going to tell it step over, right, and then at this point it will just stop the code. Right, at that point the program stops. Okay, so what's a debugger? Well, you just saw what it is, right? It basically lets you stop the program. It also lets you do things like if you want to watch over specific variables, you can add them to a watch list and look at them. But guess what? You can do the same exact thing by just doing the little, debug thing that this exercise is teaching you. All you got to do is throw in some couts, show yourself the variables, and that's it. Most of the times that's all the debugging you need to do. Okay? But it's a very useful tool to know, and to be able to use it one day for a bigger scale project. Okay, so 44, last one, or for Tuesday. I guess I'm gonna stop there, and then we'll talk about the midterm when we get to it, or I'll tell you about the midterm too. Okay, so this one is write the function with the given prototype which returns a random number between min and max to the main, right? And you would think probably, if you were thinking about it, why didn't they come up with this thing as part of the language in the first place, right? How hard is it to write this and include it into your C++ language? No, we got to go and include the time, and then do the SRAND, and they have to do the max plus the rand, parentheses, max minus min plus 1. You have to do all that math just to get a random number out. Well, we're going to simplify our lives by writing a randin function. So from now on, if you ever need to make a random number, call your function, right? And this applies to, for anything that you work from now on. You're welcome to, save your code and reuse it. That's okay. You already wrote the randin function, use it. In fact, for the final project that I'm going to give you, you're going to have to do these kind of things. I'll tell you, okay, use your randin function to make a bunch of random numbers. Then use the sum function to sum the numbers. Use the max function to find the max. So it's just different ways for you to, different tools that you already know how to use. You build them yourself, then you know how they work. You don't have to go and reinvent the wheel every time. Okay? Build a library of functions. That's what we're going to do. All right, so I guess I'm just going to tell you a little bit about the midterm. It's right there, right? So you can look at them. All right, there's a multiple choice. I think that one is set up so you can only do it one time. Yeah, there's no time limit. There's no multiple attempts. So try to do it right the first time. If you totally screw it up, let me know. I can reset it for you. Okay, no big deal. But let's not go there unless we absolutely have to. Okay. So that's that. The multiple choice is going to be things like, okay, you have this loop right here, and how many times is it going to happen, or like what is it going to show, right? Just the basic things that we covered. That's going to be in the multiple choice. Then you have one, debug a program without a compiler. Right? I'm going to give you a program. Right? It's a picture of a program. Right? And the idea for you is to figure out what's wrong with this code without typing it in the compiler and running it. Right? So let's just practice with something else that I have in here. So debug review. All right? So I have the debug review. Right? I has, let's see, review this. There we go. So let me save this thing. I'll put it on the desktop. Let's go with downloads. There you go. All right. So let me try to maybe make this a little bigger. All right. So let's just walk through this real quick and just you tell me if you see something wrong. All right. I'm going to turn this little edit thing on. Does it work?
How do you mark on the midterm? You just mark up the picture?
You can just give me a list of things that are wrong with the thing. Like for example, if you look at this right here, you can either just write the line that's wrong and what's wrong with the line. Just put it in a text file. That will be the easiest thing. If you want to, you can go in there and write on the thing itself. In Windows, you can use the snipping tool. If you don't know what the snipping tool is, I could fire up the virtual machine and show you, but basically just press the start key, type snipping tool. You can take a picture with it, and then you can mark that picture with the snipping tool itself. This here, let's see if I can pick a color. I don't know if it's going to let me write. There you go, I'm writing. But whatever. Okay, so tell me anything that you see wrong with this picture. All right? Top two lines, line 1 and 2, look good to you? Looks good to me. All right? Line 4 looks good. Line 5 looks good. What about line 6?
Function not defined.
Well, function is actually defined down there. Good point. You could say function prototype is missing, but there's also something wrong with how I'm calling it. What's missing? We're missing semicolon. This thing's not right. There you go. There you go. Semicolon is missing. All right, this line looks good. What about the next line? Line 9? There's a couple of things wrong with it. Parentheses. I saw someone gesturing at parentheses. There's your parentheses. What else is wrong with this line?
No brackets.
That's one. Yeah, it looks like the way it's indented here, it looks like we want to do curly brackets. If I can do the curly brackets. Damn, that sucks. Yeah, it just sucks. All right, curly brackets. Yeah, you can't even tell freaking curly brackets on this thing. But there you go. Curly brackets are missing. There's something else wrong with line 9. Huh? How do you check if something is equal? Yes, it's the equal, right? You need one equal. Come on, right? Yeah, we need two equals. This thing sucks. I should have
Just
just.
know it's there.
Yeah, there you go. One and another one. There you go. Equal. All right. What else? Compute, right? Again, we're missing a prototype, and okay, it looks kind of right.
Well, the C out.
Yeah. What's wrong with cout?
The,
Yes, semicolon.
yes, the parentheses,
Quotes.
quote right there. And
Right.
then where it says by, it leaves a semicolon.
Shit. Yeah. Well, let's just
That
say
works.
we'll
Yeah,
just
at least
we'll just
know.
point out the errors. I'm not gonna mark it, right? So we're missing quotes here, right?
And the semicolon on the by.
Where? By here. Okay. Semicolon there. What about this CN repeat? Yeah, looks good. All right. Return 0. What else we got in here? Then you have a cout here.
Needs a semicolon.
Needs a semicolon at the end. What about this stray parentheses? Gotta go get rid of that. All right. Then
Use an N. Right? That's what you're trying to do in the line.
this here.
Yeah.
Okay, sure. I was trying to do that, but where is this supposed to be?
In front of it.
Inside the quotes, like this, right? And then cout, right? There's something wrong with this thing again. You have comma in here. You have this variable, right? How about this function? Compute.
Needs a semicolon actually, but keep
Okay, but also what data type is piece per pod?
Needs to be defined.
It needs to be something, right? Either int or whatever. Int makes sense. So yeah, missing semicolon, missing the data type in front of it. Int numpods, right? That looks right. There's the cout looks right. Cn is obviously missing something, right? You got to do the greater than, right? Total piece is equal to piece per pod plus numpods.
Can't mix strings with.
Can add a string with an integer, right? So numpods is actually just a variable, so no quotes around it. And then cout you have this, right? Something. So you have to do less than here, less than there. There you go. So if you go in there, let's ignore this garbage and have a look at what I have. All right, you're gonna see that. Yeah, missing prototypes for all the function, missing the parentheses. I guess the call. I guess we skipped how I call this thing. Wait, that was in the. No. Okay. So yeah, all the bugs that were in this thing, I have it in here, right? All that good stuff is in there. The stuff that we discovered. And yeah, similar to this is what you're going to do for the midterm. There is a debug without a compiler. This is what it looks like, right? It's going to have, there are 15 bugs. I'm asking you to find only 10 of them. That's pretty reasonable, right? Don't stop at 10, okay? Because a lot of times, this is the number one problem that, I'm seeing is students are going to go through this and they're going to like, all right, I found 10, I'm good enough. But you didn't find 10. Maybe the 10 that you found are not really all of them bugs, right? So keep going until you get like maybe 12 or 13 or as many as you can, and then call it a day. If you can find all 15, good for you, okay? And then try not to use a compiler. All right, you're in an honor system, so I can't watch what you're doing, but I hope you're not going to cheat on this, right? And definitely do not turn in a CPP file, because if you turn in the CPP file, that tells me you typed this thing up in the compiler. It's like you're giving yourself away. So don't turn in a CPP file for this, or I might just give you a 0. All right? So that's that, right? So you have, similar thing. It's got a bunch of bugs in there, just the normal stuff. Go through it, have a look, and the bugs are going to be similar to the ones I showed you. Okay? So that's that. Then 2 functions. The midterm, right? So we did plenty of practice with functions, and that's why I pushed the midterm to be on week 4 and not earlier, so that you can, get under your belt a few of these practices that we did with functions. So if you've done all these assignments up to 44, this is not going to be hard at all, right? All it's asking you to do is, let's have a look. All right, write both functions and test them both from the same main, right? I've seen some weird stuff that people do, like they start writing 2 mains and stuff like that. You can't do that, right? Every program has 1 main. You can't have multiple mains in the program. All right, you're going to submit 1 file with both functions in it. Okay, one function returns a value, which is a random number between 11 and 23, right? And in fact, if you want to go ahead in there and use your already written rand_in function and plug in the correct numbers that you want, I'm okay with that. Okay. So returning a value and showing that value from the main is worth half the point. So basically, know how to call the function is half the points, and the other half the points is knowing how to make a random number. And again, if you've been doing the homework, it will be a piece of cake. And if you haven't, well, that's on you. Okay? So that's one. The first one returns a value. Everybody know what the function that returns a value is? Anyone want me to give you a clue? All right. Let's do this. So this is a function. This is the midterm hint. All right? Midterm hints. All right? So this is a function that returns a value. All right? Let's call it int return val. All right? And let's just, I'm going to return the sum of 2 things, right? And it's going to be int A, int B. All right? That's my prototype. Get this thing. Get rid of my breakpoint. All right? Throw this in here. Okay? And I'm just going to say, all right, int sum is equal to A plus B. And then you do return sum. So a very common error is students don't know how to return a value. They don't know how to call a function that returns a value, so they'll just do a cout sum. No. Okay, you lost some points there automatically. It has to return a value. How am I going to call this thing? Cout return val, and give it like 2 numbers. That's it. That's all there is. Okay? That's a function, calling a function that returns a value. So midterm hint, calling a function that returns a value. All right? And this is your midterm hint, function that returns a value. That is here. Okay? All right. The other one is write a void function which takes 3 float parameters, num1, num2, num3, and then the function displays the largest number. Okay, you already had to do an assignment similar to that, right? Except keep in mind that this function is going to not return anything. Okay? So again, if you don't know what a parameter is or what void is, that's where people lose the points. Not that it's a hard assignment, it's just, if you know the terminology, it's a piece of cake. Okay?
But in this case, you would do a cout in the function.
I would do a cout in the function. So let's say I'm going to do a function which, all right, let's do this. A function, what am I going for? Largest here? Largest. Okay. So let's do 2 values. So void, this is a function that shows the larger value. All right. And let's say you have show val, right? Int A, int B, semicolon, get this thing, throw it here. Okay. So a function that shows the larger value, right? If A is bigger than B, cout A, right? That's it. And then you got to write the other if also, of course. How are you going to call a function? You should know this. I hope you do, right? So this is calling a function that shows a value. So all you got to do is, that's my function, show val, and then give it like 1, 2. That's it. Okay, so just super basic things. And again, if you've done the homework, I'm preparing you for success. It's not rocket science. This is not hard, right? If you've done the homework. Okay, last one, the longer program. Let's see what this one is. All right. So remember the little triangle thing that I had you write? That's why I had you write it, because now you're going to have a freebie on the long program on the midterm, right? So what you have to do is write a program that accepts the lengths of 3 sides A, B, and C of a triangle. The user enters this, right, the A, B, and C. You have to make sure that the numbers are all positive. So remember a while loop that goes on forever until they enter the numbers correctly for every value. There, let me show you. So this is midterm longer program, right? Validate. To validate that the number entered is positive. So let's say you have int num, or let's call it C. I don't know if I have a C defined already. No, I don't. All right? Now I'm going to do while loop. Do, right, while C is less than 0. So if it's a negative value, keep asking. So C out, please enter a positive number. Okay? And then you do a cn, and then C. That's it. Right? So that's the validation. Get it right, you're going to get lots of the points. All right. And then the program output should indicate whether or not the triangle is equilateral, right, or isosceles, which is not equilateral, right? So keep in mind that equilateral is also isosceles, right? So test them in order. First, make sure it's equilateral. If it's equilateral, show that, and that's it, right? But if it is not equilateral, then you're going to go and check if it's isosceles. What's isosceles? I tell you right here in the hints. So the validation business we already did. Equilateral means the 3 sides are equal. Of course, I'm not giving you the syntax. I'm hoping you can write it. The right triangle means a squared plus b squared is equal to c squared. Right? You got to check all the different sides. You got to check to see if a squared is equal to b squared plus c squared also. Right? Check for all the 3 different sides. And isosceles means that 2 of the sides are equal. Right? It's got the same sides. 2. Okay? And that's it. If it's none of these, so if it's not equilateral, if it's not right, if it's not isosceles, then you tell them it's some other kind of a triangle. Right? And that's it. But be sure that the program can repeat. So they go in there, and these are your test values. I give you some different numbers in there so that you know how the program should work. Right? There's a test for equilateral. There's a test for isosceles. There's a test for a rectangle. There's a test for some other kind of a triangle. And then at the end of this whole thing, notice at the end of each of these, you ask the user, do you want to repeat? Yes. Right? So make sure that you test your program for all 3 cases. Okay? And that the program repeats. If it doesn't repeat, you're not going to get all the points. Right? And that's it. So not very hard at all, I think. If you've done the work, piece of cake. And if you haven't done the work, too bad. Okay? So, any questions? That's all we got to do for this week. Right? So, do the practice.
Is there a timetable to getting the midterm done?
Just as the usual, just if you turn it in by the end of the semester, I'll grade it for 4 credits. But if you want to be able to get your points back and correct the thing, do it early so that I can give you feedback.
So since I've been kind of like just going into the quizzes and like taking them to the best of my ability and fixing them, in this case, do you just open it, look at it? Can you like save, or do you need to like?
There's unlimited time on the quiz.
Okay.
Yeah, you can. I'm not sure how Canvas works with these things. But there's no time limit. I'm just not sure if it will save the answers as you enter them. Does it save them? Okay, good. One good thing about Canvas. Yeah, so it's it should be a piece of cake. You have a take-home midterm that you can resubmit, right? And I'm giving you plenty of hints, right? There's
Is this how your
no,
classes go during the fall and winter?
what's that?
Is this how your classes go during the fall and winter? Kind of?
I make it a little more difficult for, no, actually it's about pretty much the same. Yeah, that's the idea. Question? Later? Okay. It's not about this? Okay, yeah. Any other questions? That's it. So that's all you got to do. You have to do 1, 2, 3, 4, 5, 6, 7, 8 assignments with functions. Then do the midterm, which you saw is not that hard. You should be able to go through these probably in one day. Okay? That's all I have. If you don't have any
I have
questions.
a question for you, just something I read.
Okay, I'll look at it right now. So let me just unplug this so I can stop the video. And then I'll upload all this good stuff for you. I still got